Here we're going to talk about square roots, or sometimes we call these radicals. They both mean the same thing. At the end, we might also call them irrational numbers, but that just depends on what your final answer looks like. If you get a long, crazy decimal that doesn't repeat, doesn't terminate, we call that irrational because you can't write it as a fraction or as a whole number. So let's look at an example here. This problem is saying between which two consecutive integers would the radical be located? Use the integers to estimate the radical. And remember, this just means square root. Radical, square root, they mean the same thing. So what I can do here is just first start by listing at the top of my paper, what are all the perfect squares that I know? For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3, or we could say 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 times 8 is 64, 9 times 9 is 81, 10 squared is 100, 11 squared 121, and let's go up to 12. 12 squared is 144. All right, I can do these so quick because I just have all my perfect squares memorized up to 12. Really, you should memorize these. It's going to make your math life so much easier. But what I want to do is I want to use these to estimate this radical. So here I have radical 96, or square root of 96. And I notice 96 is in between 81 and 100, right? It fits in between these two perfect squares. So I can say radical 96, it must be less than radical 100, but it must also be greater than radical 81. All right, and I'm going to use these two perfect squares to estimate what is the square root of 96. So square root of 81 is 9. All right, and I'll just bring down this. And the square root of 100 is 10. So I know that when I square root this, without a calculator, when I square root this, I know that it's going to be in between 9 and 10. 96 is closer to 100 than it is to 81. So I would guess this would be around, 9.8, maybe 9.9, something like that. You can check it with your calculator, maybe 9.7, but it's going to be approximately 9.8. That's what this curved equal sign. I'm not using equals because it's not equal to. It's kind of estimating. It's approximately 9.8. All right, and you might get some answers that are a little bit around that. 9.7 is fine. 9.9 is okay too. Okay, let's do a harder example here. This is still kind of the same question. Between which two consecutive integers would the radical be located? Use the integers to estimate the radical. This one's a little bit trickier though because I have the square root of 216, which you might notice is larger than any of the perfect squares. So let's just keep going. 12 squared was 144. 13 squared is 169. I know all of these already because I'm a math teacher, so I have lots of things memorized. Next would be 14 squared is 196. 15 squared would be 225, and I think I could stop there. So 216 is in between 196 and 225. So let's write that like this. It's going to be less than radical 225, but it's going to be greater than radical 196. All right, so we're going to use these to estimate this radical again. The square root of 196 is 14. Just bring the rest down. And the square root of 225 is 15. All right, so I know that when I'm estimating this has to be in between 14 and 15. It's going to be 14 point something. So just kind of looking at where this is, it looks like it's a little bit closer to 225. So I would guess approximately 14.7, maybe 14.8, 14.6, something around there. As long as you're close. And again, notice I'm using these squiggly equal signs because it means that I'm estimating. It means it's not exactly 14.7. It's approximately around there. All right. Let's do one more. So I've got a hard one here, saved for last. 9 times the square root of 245. And this one I know is, remember, 15 squared was 225. So I know it's going to be bigger than that. Our next perfect square would be 16 squared. So 16 times 16 is 256. All right, so I know that this is going to be in between those. Also at the end, I have a 9 out here. So at the end, I will need to multiply that 9 back into the radical. All right, so square root of 225 is 15. And just bring that down. Square root of 256 is 16. Again, I have all these square roots memorized already. You might not, but definitely something you should work on to make it a little bit easier for you. So I know that this is going to be in between 15 and 16. I think it's kind of closer to 16. It's closer to 256. So I'm going to say this is approximately 9 times, let's say 15.7, maybe 15.8, something around there. And for the last step here, I just need to multiply this 9 back into that radical, back into the square root. All right, so 9 times 15.7, you're going to get about 141.3. Maybe something a little bit different. As long as you're close, that's fine. You might have 141.2, 141.4, something around there, something kind of close. So let's talk about these irrational radicals. They all gave us decimals at the end. We can't write them as fractions or whole numbers. They're going to give us decimals. So let's say, first of all, what's the difference between rational and irrational? Is just simply rational numbers can always be written as a fraction. Even if you have a whole number, that can also be written as a fraction. You just divide it by 1. Irrational numbers cannot. You can't write them as a fraction because they make decimals that don't repeat and don't terminate. We call these irrational. And if we look at our number system here, the real number system, so not including from Algebra 2, this doesn't include complex numbers, non-real, imaginary numbers. Rational numbers are, like 2/3 is a fraction, or 0.111 repeating, any integer, a whole number, any natural number. These would all be different types of rational numbers. Irrational numbers cannot be written as a fraction. If you type pi into your calculator or radical 3, square root of 2, these all give you non-repeating, crazy, non-terminating decimals. All right, so that's the big difference here. If I add two irrational numbers together, the sum of two irrational numbers, it's always going to give me still an irrational number. Same thing with multiplying. If I multiply rational times an irrational, that decimal is just going to carry on to the answer. It's going to still give me an irrational number. All right, so that's the basic difference here, rational, irrational, and how we can approximate these radicals using perfect squares that we already know.